So welcome everybody to Bridging the Gap with the optimal workflows for the civil industry. So here's our agenda for today. So we're going to start off by just doing a quick overview on current industry trends. We'll then take a glance at the Autodesk Infrastructure Design Suite and see what it contains. We'll then take a look at how to aggregate existing data to develop your models. We'll then take a dive into Recap 360 Pro to show you how to process your scan data. We'll then move into InfraWorks 360 where we'll develop our conceptual model. And then we'll then take our conceptual model into Autodesk Vehicle Tracking to analyze our flow conditions. And then finally, we'll look at how to present our design proposal. We'll then just do a quick review, a recap on conclusions of things we've covered for the day. We'll finish off with some Q&A and then discuss steps going forward, where you can go next. All right. So from that, let's get rolling. So let's first start off talking about current conditions, current issues. So in the industry, trends in the road and highway market, road and highway engineer professionals around the world are facing many challenges. Infrastructure is crumbling, and that same network of roads and highways is seeing increased traffic flows. Budget shortfalls are being caused in part by declining gas tax revenues and material costs. The adoption of automated machine guidance is prompting many roadway agencies to consider alternative construction deliverables. With governments around the globe committing unprecedented funds to transportation infrastructure projects, the challenge in the industry will be to make the best use of that funding to deliver high-quality projects faster and more economically than ever before. So, never before has ROI been more important, return on investment. Let's take a closer look at how BIM can deliver improved return on investment. Recently, Stanford University Center for Integrated Facilities Engineering conducted a study and found that based upon 32 major projects using BIM, there was a 40% elimination of unbudgeted changes, cost estimation accuracy within 3%, up to 80% reduction in time taken to generate the cost estimate, a savings of up to 10% on the contract value through the clash detections, and then up to 7% reduction in project time. So now let's take a quick look at the Infrastructure Design Suite. So the Design Suite comes in 3 different platforms. You have the Standard, Premium, and Ultimate editions. They all come with the foundational standard products, which include things like AutoCAD, Map 3D, Raster Design, Recap, Storm and Sanitary Analysis, as well as Navisworks Simulate. And then as you move up the ranks into Premium and Ultimate, you then obtain additional products such as Civil 3D, InfraWorks, 3D Max, and so on. So first, now let's talk about how to aggregate our data. So there's lots of data out there that's available to you, readily available to you at no cost. And this is kind of where you want to start off. You don't want to spend a lot of time or money researching existing conditions, primarily for a proposal or for a concept idea. So there's a lot of different places out there you can get free data. So primarily, I like to start off going to places like the USGS website. They have a national map viewer, which will allow you to search, zoom, and navigate anywhere you like, and then select an area to identify the different downloadable products that you'd like to receive for that area. And on there you can get elevational data, topography, imagery, LiDAR data, so on and so forth. You can also go to NOAA, city, county, and DOT websites, as well as various GIS sites that are throughout the internet. FEMA also has quite a bit of information. And as we'll see also, the Autodesk has what we call a technology preview currently provided with InfraWorks called the Model Builder, which will allow you to zoom to any given location and then select an area, give it a name, and via cloud-based service, it will generate an existing conditions model for you with whatever data is available, and then they'll just email it to you. So that's a great resource as well. And then you can go to other places such as Google Earth and the Trimble Warehouse to additionally obtain other information. So for today's demonstration, I've chosen the city of Berkeley, California. And on the slide on the right-hand side, you can see that I've decided to access the USGS website. And from there, I was able to obtain elevational data, LiDAR point cloud information, and ortho imagery. And then also via the city's GIS website, on the left-hand side, you can see I was able to get things like parcel data, street networks, land areas, parks. I also believe I got the trees for the city, the sewer and storm drain systems, as well as the roof footprints for all of the existing building conditions. So because I was able to receive that LiDAR data via the USGS site, first thing I would typically start off by doing is processing that through Recap. Now, one of the things you'll find on that site is it can be very gridded up into small sections. And, just your luck, you'll probably end up where your project is right on the middle of a grid line or in the middle of 2 or 3 or 4 grid lines. So utilizing a product like Recap to assemble all of those scans and process them, clean them up, get them ready for use in your model is an ideal workflow. So Recap basically comes in 3 platforms. You got your basic Recap version, which is again is for processing your scans, utilizing some of the basic standard features. Pro version gives you a few additional functionalities, things such as snap registration, as well as tying in existing survey control to 3D data. So that's pretty handy as well. And then you have the Recap 360 version, which kind of the next level above that. It has a bunch of additional cloud capabilities, cloud features, web services for sharing and collaborating on scans. And it also has the addition of the Recap Photo 360, which allows you to generate scans based on imagery, which is a really handy little tool. So it's basically a 3-step process. So you start off by importing your data. Once you've selected your scan or your list of scans, you then go ahead and do your registration or translation, if you will, onto a different coordinate system if need be. And then finally, you can navigate, clean it up, get it ready, crop it out, and send it off to be utilized in other products. So let's take a look at that real quick. So here is Autodesk Recap 360 Pro. So typically you'll start off on a basic front end like this. I'll go ahead and choose to create a new project and give the project a name. I'll just accept that for now. Then you can drag all the files you like right onto this target, or you can choose to browse, navigate, and select whatever data you may have downloaded. And again, this is really handy if you've gotten several files. I know a lot of times when I'm pulling down the data, I'll often pull down 2, 3, 4 scans, and this will allow me to quickly assemble them all into one single scan file. So you can see I have one file that's been processed, ready to be brought in. I'll then go into my settings. I can adjust my intensities. I'll go into my advanced options, where I can go ahead and plug in the coordinate system that's been assigned to the downloaded file I've chosen. And then I can even choose my target coordinate system to translate it onto another system, maybe a system that would more easily coordinate with the other data I've received. So quick and easy.
Hey, Mario?
Yes.
Hi. The audio is a little jumbled. Do you think you can maybe readjust your microphone?
Yes. Sorry about that. Okay. So now that we've defined the data and the coordination, and to expedite things, I've pre-processed this file. So you can see that this is the scan information that's been received, and pretty nice little elevational model, especially since we were able to pull that down very quickly, no charge, things like that. Gives me a nice understanding of what's happening on the current project. So better than just looking at it through a map viewer, if you will. And furthermore, it is a 3D model, so we can utilize this in our actual conditions model. So we can go ahead now, and if we needed to, we could crop this into an area that's going to work for us best, and trim it out if we need to. So if we choose to use just a small portion, or a portion where our project happens to be located at, we can do that. And finally, once we get done, we can just choose to save this, and it'll save out as a recap file, RCP file. So you can see that right there. And the RCP recap file can be imported and processed into products like AutoCAD, Civil 3D, Map 3D, InfraWorks, things like that. So very handy little tool. But as you can see, the standard LAS file that I was able to download comes in great into recap, but that's not a import option of a file type for some of these other products. So the RCP file will be the perfect solution for bringing in this data. All right. And a quick little case study regarding recap. NASA actually recently used it on the Hypersonic facility complex. And as you can see from this information, it was quite a big project, 129 scans a day. They used a FaroFocus 3D module. And you can see, based upon this information, they considerably reduced their processing time down to 4 weeks, which was initially 16 weeks in total. So 75% time savings, which is an excellent feat. So now let's take a look at InfraWorks 360. Autodesk InfraWorks is part of the overall Autodesk BIM for Infrastructure solution. Remember that BIM is about creating and using 3D intelligent model for planning, designing, building, and managing infrastructure, with an emphasis on creating and using intelligent model. So it's broken down into 3 value themes we recognize when we review BIM for infrastructure. Clarity, as in using the intelligent model to gain a clearer understanding of the project and to use it more clearly to communicate the project proposals. Continuity, as in having the ability to use the same data for greater consistency across the project lifecycle. And then agility, which is being able to respond quickly to changes within the process, smarter and faster. Preliminary design and engineering is an important and often forgotten phase in the lifecycle of an infrastructure project and can benefit from the BIM infrastructure workflows. Work completed between the planning and design phases is needed to confirm scope, budget, and schedule. Autodesk InfraWorks provides an added value to civil infrastructure projects in this phase. So, InfraWorks 360 can receive various types of data through the products included in the infrastructure design suite. So you're able to very quickly import and connect to data in products like Civil 3D, Navisworks, Map 3D, Revit models, and 3D Max, as well as various other data file types such as 3D models and GIS data and raster imagery. So let's take a little bit of a closer look at the connection types. So when you're in InfraWorks, you can see there's a lot of different data source types that you can receive. So existing models, again, from something like the Trimble warehouse, you can pull down SketchUp files, FBX files, OBJ files, Autodesk IMX, which is the proprietary InfraWorks file extension type for processing InfraWorks files across the infrastructure design suite. You can also connect to various things like point cloud LiDAR data, such as what we just reviewed, raster imagery, Revit models, GIS data, so on and so forth. So now let's take a look at working with InfraWorks 360. So to kind of cut down on time a little bit, I did pre-process the elevational data and the aerial imagery that I received from the USGS website. And so was very quickly able to develop an existing conditions model utilizing that various information. I was then able to connect to that other information that I was able to receive, such as the water bodies. I'll turn those on. And even the road networks. So I'll turn those on as well. And you can see models really starting to take shape now. So I've got my water bodies, a little lake in there, and my road networks. We can further enhance our model with some of the other data we've received. So let's take a look at some of that. So if you recall, it also had our buildings, so able to bring those in. And now we're really starting to get a more completed model. We also had trees, so we're able to bring those in. So now our model actually has a very accurate representation of all the existing trees that were out there. So again, further helping us understand some of the more eco-friendly decisions, like what trees might need to be worked around, protected, and what will be eliminated. And then we also had the ability to bring in the utilities, so I brought those in as well, storm and sewer. So now as we navigate around, let me see if I can find a little something for you. Probably more in the city area. You can see that it does accurately show all of the utilities. So we can locate the manholes and the other utilities that we might want to connect to. So those are all accurately represented now throughout our city. So now let's take a look at bringing in that recap LiDAR scan file. We just processed that in the previous steps. So we brought that in, and you're able to stylize it and generate theming for it and so forth. So now when we bring that in, we'll be able to further see the existing conditions a little bit better. So now you can see as that LiDAR scan file comes in, now it's overlaying onto our model and helping us really understand what's really happening out there in the world. Helping us, again, further complete our model to get us a more accurate representation of our existing conditions. So the next thing you would typically do is, once your existing conditions have been developed, it's now time to start deciding, what your design proposal is going to be. And identify your site location, and then start laying in your conceptual design information. So I'm going to zoom out, identify a location. Maybe for the presentation, I might turn the point cloud off just for a little bit faster performance. So I'm going to switch to a basic proposal that gives me a little outline of kind of where our roads are going to be and what we're going to do. So we can then start conceptualizing what is our design going to be. So we can lay out our roads just by simply going into creating new conceptual features. Choose to bring in whatever type of road I want to bring in. And maybe I'll connect down to here. Very simple to make changes. We'll make something very irregular. Double click to reconnect. Gives you a basic road layout very quickly and easily. So you can see a pretty accurate little intelligent road model. Select that. I didn't make that a design road, so I'll turn that into a design road so I can utilize some of the vertical options as well. So now, when I look at my design road, you can see I've got various PIs, and I can adjust things horizontally and vertically. If I choose to, I can show the profile. I can manipulate the design through the profile, adjust vertical curve sizes, things like that, and then get summaries on the earthwork and material construction quantities that are going to be required to develop this. So very quick and easy to make these types of changes and decisions. I can also come up with several different proposal types, several different decisions on methods that we're going to propose for creating this project, and get it all laid out just the way we like it. And once you come up with a design you're happy with, the next thing you're probably going to want to do is analyze it. So there's a few analytical tools in InfraWorks that you can use. But for our purposes, I think we want to go ahead and test some of the turning capabilities in a product like vehicle tracking. So very simple and easy to go ahead and export your model out to a IMX file. If you recall, that's your resident InfraWorks file type, which can be received by many other products. And so this gives us the opportune time to go ahead and start looking at something like vehicle tracking. So the vehicle tracking software is a comprehensive transportation analysis and design solution for vehicle swept path analysis. Vehicle tracking is an essential addition to the Autodesk Civil Infrastructure software portfolio, providing benefits to civil engineering teams working on transportation and site design projects. Autodesk Vehicle Tracking overlays onto several of the suite products, so it's a add-on module onto products like AutoCAD, Map 3D, Civil 3D, AutoCAD architecture, and even utility design. So most infrastructure projects require some type of analysis to determine proposed roadway geometry can support the movement of various vehicle types. Using vehicle tracking, we can determine these things very quickly. The software comes with an extensive library that contains design vehicle definitions from all over the globe and over 500 vehicles. And it also includes constraint and standard information for companies like AASHTO, Caltrans, Main Roads, FTA, and departments of transportation. So it can accurately just depict how those movements are going to handle horizontally as well as vertically. It can also consider safety factors. So being able to analyze things like sight distance, adding sight lines, design speeds, and as well as comfort of driving, a wheel axle articulation, blind sights, things like that. So all of this stuff is available and able to quickly analyze from the existing conditions model that we've already developed. You can also do additional performance design checks, if you will, generating, again, articulation diagrams, vehicle diagrams, and then even color schemed modules to help present what your analytical performance happens to be. Again, we also have vertical clearance analysis, which will help ensure that the vehicle types that you're testing for are not going to bottom out or ground out on crust or sag curves in your design. It'll also check for height clearances too. So if you're going under bridges, tunnels, things like that, you want to make sure that everything's going to fit properly. So let's take a look at that now. So here we have the export that we were able to take out of the InfraWorks model. So you can see it brought in the surface conditions as well as our road layouts, and then the proposed profiling design that we've done. And if you look over onto your prospector, you'll see that we have the various surfaces and alignments and things that have already been developed for us. So obviously you need to start with a good quality Civil 3D template with the styles and such that you would like to utilize for the visual performance you'd like to achieve. So let's take a quick look now. So vehicle tracking, again, it comes in as an add-on, so you get to see it as an additional ribbon tab up on your ribbon. And so in here, we'll go ahead and flip to that tab there. You'd start off by typically going over to your settings, and then in here you can go ahead and choose your unit types, and then your distance units, your speed units, angular units, layer conventioning, and then your design speeds, stuff like that. So pretty straightforward. Again, there's a pretty extensive vehicle library. So from all over the country, anything you want to get. Now, you can't edit these ones. They keep them in there kind of set up so that you always have them available to you. But you do have the ability to copy any of these to your own custom library and then modify those at will. So pretty easy to manipulate these. So you can adjust them based upon plan view and axle, look at profile, generate diagrams. Quite a bit you can do with this library. So there's a lot of different methods for laying out your drive analysis. You have the Auto Drive Arc, which will allow you to kind of interactively lay out your road design. You have the manual drive, which kind of works like a little video game. You have the video controls and you're just kind of driving on your roadway. Vertical clearance, we'll see that as well for checking vertically. A guided drive, which will allow your vehicle to drive along a polyline or some type of object segments. And then templates. So let's go ahead and use just the Auto Drive Arc. It'll ask me again which vehicle I'd like to use, and I'll just I'll pick a service truck, and I'll say proceed. And it'll ask me if I'd like to make this my default vehicle, and no, I don't. It'll again have me check my settings. I'm just going to accept the defaults. And now you can see that that vehicle is attached to my cursor. So I can then go ahead and just click, place, and now it's looking for an angle. So obviously the farther out I pull, the more accurate, precise I'm going to set my angle. It brings up a dialog box for my vehicle positioning. And if I kind of oopsed it, maybe I clicked the wrong angle or something, I could use any of these tools to clean that up and modify. I'm just going to say proceed. So now I have another little dialog box kind of hiding off in the corner. And you can see I've got the vehicle attached to my cursor. And it's showing me the maximum turning radius of this vehicle. So I can just go ahead and click and place. If I oops, I can always just back up and remove spaces, things like that. So no big loss there. I can also choose to move on an alignment, selecting this alignment here. It'll accept this bearing. Or I can tell it to stop and turn on a spot, which will give me a much more precise turn, as if I was actually stopping at the intersection. And then click and place that. Continue to move around and place the vehicle. Just verifying that it's actually going to be able to fit, maneuver about this. There we go. And escape. And then there's my vehicle layout. So I can adjust this if I find that some of the data, some of my picks weren't exactly where I wanted them. I could just adjust those. I could add additional points if I needed to. I could remove points. And then I can just go ahead and test this out to see how this is actually going to perform. So I'll just go ahead and do a animate, brings up the animation toolbar, and I'll just tell it to go ahead and drive. I'll speed that up a little bit. And we can now see that vehicle perform its turning along the proposed roads we've been designing. We can also choose to look at this in a three-dimensional mode, where we can start that over. And then we have interactive controls where we can move and position ourselves however we like, generate animated preview, and then we can even export that out to a recorded video that we can play for other people or even send to other people so they can see this without actually having to own the software itself. All right, so I'll go ahead and close that. That looks pretty good. I can then go ahead and choose to place additional vehicle outlines along my path. This is great for exhibits, presentations, demonstrating the turning ability of the vehicle in case there's question on the tightness of your design. You're able to quickly place the vehicle outlines in all the necessary or key locations so that you can demonstrate that properly. Okay, so now let's take a look at the vertical clearance options. So I'm going to go up to vertical clearance. Again, it'll allow me to select which vehicle I'm going to test with. And then I'll come over to my profiles and I'll pick my design profile. It'll just give me a notification letting me know that this vehicle has a lot of default values, and if I don't set up any of the specific values I want, it's going to utilize those. I'm just going to accept that and say go ahead. And being that my vehicle is now placed from beginning to end, that does show me that this design does work very well for this vehicle type. If it stopped anywhere along the way, it would let me know that there's going to be a spot where it's going to conflict with something, and then I'd have to refine my design a little bit. So I'll do it again for the next street. Accept the values, and that one looks good as well. And I'll do it one more time for this one. And they all look good. Excellent. So I can move on with my design now. So next, after you've come up with your design concepts, you've analyzed it, you've checked everything, and it's all working out very well, one of the next things you're typically going to want to do is present your design, generate a presentation for what you've come up with. And again, InfraWorks is great for that. It will very quickly optimize your road design. It will give you the estimated earthwork costs and quantities, and it'll give you your material costs and quantities. So lots of intelligent feedback immediately from your design and planning elements. Nothing that has to be equated after the fact. You can also see the slide here on the left-hand side is a output rendering you can do. So if you decide, hey, this is what we're looking to propose, now you have something more appealing that you can take to your stakeholders, take to your clients, or public hearings, as opposed to just a set of engineering plans, so that often can't be read by people that don't really understand them. So you can get nice renderings, get nice reporting outputs, and then you also have the ability inside your InfraWorks to generate animations as well. So I have a proposal that's a little more complete. And so now it's very easy to present this to whoever needs to understand your design concept and your approvals. So what we have is we have our presentation tools where we can come over. We have our storyboard creator where we can put in different camera paths, camera options. We can put in captions, titles, little notes and points about various locations throughout our site. We can put in different camera effects like zooming, panning, craning around, different stuff like that, fade in, fade out. Various things like that to really convey our design intent now. So once you have all that in there, it's pretty simple to just zoom to a location and then drag that snapshot right onto the storyboard. And then zoom to another location and add that snapshot to the storyboard as well. And as you continue to do this, the software will seam those together and transition from site to site and location to location, generating an animation for you. And when you get done, that animation can be played live or can be exported out again to a video file format, an AVI or an MPEG or something, that again you can post to a website, you can email to somebody. And then we also have the 360 tools, which will allow you to upload your model to the Autodesk cloud service, where you can then host it and invite other people to see it. And then they can now open that model, navigate about that model, and see your design real time without actually having a copy of the software. So that's very handy as well to get buy-in with again, not having to send large files. So when you get done, you can see that very easy to make nice presentation materials that allow you to really convey what your design intent was going to be, to again further get that buy-in you're looking for on a more intelligent model. Now, the nice thing about this too is nothing we've done is a waste here, because once you get that buy-in you're looking for, or at least that feedback from your design, adjustments can be made here, and or this can be, as you saw, sent directly into something like Civil 3D, where the engineering can be further refined and construction documents can begin. So you don't have to start over. Planning is no longer a separate phase. It can now be the starting point and the foundational basis of your design plans. So going forward, that becomes a very handy little tool. So just to kind of wrap what we've discussed today, we did talk about industry trends and the current economy and conditions. We discussed the Autodesk Infrastructure Design Suite and the products that are available in it. We learned how to aggregate various data from locations that can provide that to you. We took a look at Autodesk Recap 360 Pro. We then looked at Autodesk InfraWorks 360. We then looked at Autodesk Vehicle Tracking. And we finally looked at how to present your proposal. So I hope this gives you a quick understanding of it. This was a workflow-based presentation. Rather than just picks and clicks on what a single product can do, kind of wanted to take you through the steps of how do I start? Where do I get my data? What do I do with that data once I've received it? And how does it translate from product to product? So hopefully this gives you a nice overview.